Hello, good morning students. Today we are going to study one important chapter, that is types of cast iron. The cast iron is a very useful ferrous metal for domestic purposes as well as industrial purposes. It is produced in the cupola furnace by remelting the pig iron. As per the iron carbide diagram, more than 2% carbon is called as cast iron. The cast iron is having low melting point, so most of the cast iron components are produced by casting process. The cast iron is a brittle metal and having better vibrations damping properties. Now we are going to see what is the general composition of cast iron, what are its advantages and disadvantages of cast iron, and what are the various types of cast iron, what is the composition, properties and applications each of them. Okay students, till now we studied about what is cast iron and what is its composition and what are the advantages and disadvantages. Now we will see what are the types of cast iron, that is classification of cast iron. According to structure of cast iron, it is classified as 5 types. They are: 1. Grey cast iron, 2nd. White cast iron, 3rd. Chilled cast iron, 4th. Malleable cast iron, 5th. Spheroidal cast iron. First of all, we will see about the grey cast iron. In the grey cast iron, the carbon is present in the form of graphite flakes. When it is fractured, it shows grey color. That is why this cast iron is called as grey cast iron. The following is general composition of grey cast iron. The carbon from 3 to 3.75%, silicon 1 to 2.75%, manganese 0.4 to 1%, phosphorus 0.15 to 1%, and sulphur is from 0.06 to 0.12%. Now we will see what are the properties of grey cast iron. First, it possesses good castability, low shrinkage during solidification, high vibration damping capacity due to free carbon, it having good machinability, and also it having low impact strength and poor ductility. Now we will see what are the applications of grey cast iron. The grey cast iron is mainly used for the following applications. It is mainly used for making machine tool beds. It is used to make flywheel pulleys, flange couplings. The third application of grey cast iron is it is used to make cylinders and pistons of small capacity engines. Fourth, it is used to make water main pipes. And the fifth application is it is used for housings of steam turbines. The another type of cast iron is white cast iron. The white cast iron is produced by rapid cooling of cast iron. It shows white surface when it is fractured. Now we will see the general composition of white cast iron is as below. The carbon is from 2 to 2.5%, silicon 0.85 to 1.2%, manganese is less than 0.4%, phosphorus is less than 0.12%, sulphur is less than 0.12%, and the remaining is iron. Now we will see the properties of white cast iron. The white cast iron having the following properties. It has high hardness, it has good wearing resistance, it has good compressive strength, and it possesses good cast stability. Now we will see what are the applications of white cast iron. It is used for chilled rolls. It is also used for wearing plates, and it is used for stomp shoes and dies, and also to make grinding balls. Another type of cast iron is chilled cast iron. This cast iron, also called as mottled cast iron, it has carbon in combined form on the surface and free form at the core. The formation of graphite during solidification depends on the cooling rate. The composition of chilled cast iron is carbon is from 2.8 to 3.6%, silicon from 0.5 to 0.8%, and manganese is from 0.4 to 0.56%. The following are some of the properties of chilled cast iron. It has higher wear resistance at surface, and it has high surface hardness. Now we will see some of the applications of white cast iron. It is used to make grinding balls. It is used to make the rolls to crush the ores. It is used to make the wheels of railroad freight cars. The another type of cast iron is malleable cast iron. The malleable cast iron is produced by heat treating of white cast iron. Comparing to other cast iron, the malleable cast iron is having better malleability. This is the composition of the malleable cast iron. Carbon from 2.0 to 3.0%, silicon 0.9 to 1.6%, sulphur is less than 0.18%, phosphorus less than 0.18%, and the remaining is iron. These are some of the properties of malleable cast iron. It possesses better malleability, it has good formability, it has better ductility, and also it has good shock resistance and toughness. These are some of the applications of malleable cast iron. It is mainly used in agricultural implements, to make the automobile parts, to make manhole covers, to make the railroad equipments, and to make gears and cams. It is also used to make the pipe fittings. This last type of cast iron is spheroidal cast iron. It also called as nodular cast iron or ductile cast iron. This iron is produced by desulfurizing of grey cast iron and adding of magnesium before casting. The addition of magnesium converts the graphite flakes into spherical shape. It contains the carbon in the nodular or spherical shape. This is the composition of the spheroidal cast iron. Carbon is from 3.2 to 4.1%, silicon from 1 to 2.8%, sulphur less than 0.03%, phosphorus less than 0.1%, and the remaining is iron. These are some of the properties of spheroidal cast iron. It has good strength, it has good castability, it possesses good toughness and ductility, it can be easily machinable, and it has good wear resistance and shock resistance. These are some of the applications of spheroidal cast iron. It is used to make crankshafts, it is used to make punches and dies, it is used to make marine castings, it is used to make gas and water pipes, it is used to make hand tools. Okay students, today we studied what is cast iron, what are the types of cast iron. In that we studied about grey cast iron, white cast iron, chilled cast iron, malleable cast iron and spheroidal cast iron. We also studied about properties, composition and applications of each type of cast iron. Thank you.
Why can't we have cast iron or mild steel ornaments? Because of human comfort and compatibility, corrosion resistance, appearance, etc. They are made with gold and silver, that is non-ferrous metals and alloys which do not contain iron as main constituent. The prominent non-ferrous metals are copper, aluminum, nickel, zinc, tin, lead, magnesium, chromium, gold, silver, etc. Now we go through properties and uses of non-ferrous metals and alloys. Properties: good electrical and thermal conductivity, that is they can easily conduct electrical power as well as they can easily conduct thermal heat. Next is good castability and formability, that is any type of casting is possible with non-ferrous metals and alloys. Formability means they can be shaped to any required shape. Special magnetic characteristics, that is ferrous metals and alloys are usually magnetic, whereas most of the non-ferrous metals and alloys are non-magnetic in nature. This sometimes find some uses. Next is corrosion resistance. Next is ductility and malleability. By ductility we mean they can be drawn into wires and cables very easily. Malleability is the property due to which they can be made into sheets and plates, such as silver foils or aluminum sheets, like that. Due to the above said properties, they find the following uses. Number 1, aircraft applications, that is aircraft wings or some other spare parts. Next is electrical and thermal conductors. Next is bearings, heat exchanger tubes because of good thermal conductivity. Chemical apparatus due to corrosion resistance. Electrical appliances. Now we go for details of various non-ferrous metals and alloys. Copper and its alloys. Properties are like this: good malleability and ductility, that is it can be drawn into sheets and plates as well as wires. Good electrical and thermal conductivity, moderate strength and hardness, corrosion resistance, easily machinable and formable, that is by machining it can be shaped to any required size and shape. Formability means that can be mechanically shaped to the required size and shape. Can be welded, brazed and soldered. You know that welding is a property of joining two metal pieces. Similarly, brazing is the process of joining two similar or dissimilar metals. Next, coming to the uses. Number 1, cooking utensils. Tubes in heat exchangers due to good thermal conductivity. Heating kettles, that is tea making containers. Conducting wires, cables, switch elements. Brasses and bronzes are the different alloys of copper. Aluminium and its alloys. Properties are like this: high electrical and thermal conductivity. Because of this they are used for making current wires. Low weight, good corrosion resistance, high malleability and ductility. Aluminium is used for the following purposes. Due to said properties, aluminium is used for aircraft applications, that is aircraft wings and other components. Electrical cables, cooking utensils, chemical apparatus, due to good corrosion resistance. Next, coming to the aluminium alloys. Duralumin, which is a wrought alloy, that is need not be cast, having the percentage of copper 3.5 to 4.5, magnesium 0.4 to 0.7%, manganese 0.4 to 0.7, aluminium is balanced. With the properties of non-magnetic resistance to corrosion, possesses good strength. It is used for aircraft and automobile engineering in the form of forgings, bars, sheets, rivets. Coming to the Y alloy, having the copper percentage of 3.5 to 4.5, nickel 1.8 to 2.3, magnesium 1.2 to 1.7, remaining is aluminium. With the properties of retaining high strength at high temperature, resistance to corrosion, is used for pistons and cylinder heads of aircraft engine. Magnesium, with magnesium 2 to 10%, copper 1.75%, remaining is aluminium, which is light in weight, possesses good mechanical properties, is useful for aircraft and automobile components. Hindalium, magnesium 3.5% approximately, and a small percent of chromium, and rest is aluminium. It is very good corrosion resistant. Due to that, this is used for utensil making. Cookers etc. are made with hindalium. Now let us go for nickel and its alloys. Now we go for nickel and its properties. Coming to the properties: good mechanical strength, corrosion resistance, capacity to retain polish, creep resistance, that is this do not undergo much deformation at elevated temperatures in a long time. Coming to the uses, nickel is used for gas turbine discs and blades. You know that gas turbine is used for generating mechanical power, which may be connected to electrical generator to generate electrical power. It is used as constituent metal in nichrome, that is the metal or alloy used for making heating coil wires. Next, Monel metal, Constantan, etc. To conclude this, nichrome, an alloy of nickel, chromium, iron, is used as heating element as you have seen. Zinc and its alloys, the properties are like this. Zinc is a bluish white metal, malleable and moderately ductile, brittle at room temperatures. That is, brittleness means this will not give sufficient deformation before its failure when it is subjected to load. The uses are like this. You see GI buckets in which zinc coating is given on iron and steel and called galvanizing. It is also used for die casting alloys. Coming to tin and its alloys, the properties are like this. Tin is white lustrous metal, very soft and weak, malleable and can be hammered to produce thin foils, corrosion resistant. Uses are like this. Tin finds indirect use such as constituent in bronze, that is copper and tin forms bronze. Gunmetal, of course it is also one type of bronze. Bearing metal, solders, that is the soldering elements used for making soldering. Coating on copper and iron as shown on biscuit tins, which is a good corrosion resistant coating. Coming to the lead and its properties, it is soft, heavy and malleable but not ductile. It has silver white color. It can be work hardened at ordinary temperatures. It absorbs high energy rays. Lead compounds are used in paints and pigments. Pigments are color making chemicals. Now we go for magnesium and its alloys. Properties are like this. Lightest of all engineering materials. Due to this, the magnesium is alloyed with aluminium to make aircraft components. Easily formed, spun, drawn, forged and machined with great accuracy. Spinning means it is done in the turning process to give shape. Alloys with aluminium, zinc, manganese, etc. Uses are like this. Aircraft engine parts due to lightweight, I already told you. As alloying element in aluminium alloys. Now we go for chromium and its properties. Silvery white malleable metal, that is why it is coated on steel articles such as stoves, gas stoves. Strong and hard, good corrosion resistance and heat resistant. Its uses are like this. Widely used as target in X-ray tubes, used as alloying element in tool steels, stainless steels. Now we go for bearing metals, alloys. A bearing is a mechanical device for decreasing friction in motion in which a moving part bears, that is, slides or rolls while exerting force on the other part. Bearing supports moving parts such as shafts and spindles of machine or engine. Selection of material plays an important role in the design and performance of the bearing. The metals which are used for making a bearing are called bearing metals, also called babbittes. Properties of the bearing metals are like this. It should have low coefficient of friction, that is very smooth surface to avoid frictional waste of power. High melting point, because the bearings are subjected to high temperatures. If it melts, it is going to fail. High thermal conductivity, due to which the bearing easily conducts the heat generated. Good load bearing capacity. Naturally, The bearing requires this because it is a load bearing element. Corrosion resistance. Usually bearings are subjected to lubrication with various lubricants which may corrode in fact, so it should have corrosion resistance. Low cost. Good compressive strength at operating temperatures. Usually the bearings are subjected to high temperatures. If it is having not sufficient compressive strength, they may fail. Types of bearing metals. There are three types: lead based white alloys, also called as babbits. Number 2 is tin based babbits, copper based babbits. Coming to the composition of lead based babbits, lead is up to 80%, antimony is 10%, tin is 10%. Tin based babbits, their composition is like this: tin is up to 88%, antimony 8%, copper 4%. The properties are like this: good resistance to corrosion, low coefficient of friction, and good wear resistance. Wear resistance means it is not going to form any abrasions when it is subjected to load or abrasion. Soft metal, self lubricating properties, that is, even if you do not apply any lubricant, it is having inherently lubricating properties. Therefore, it is used for crankshaft bearings. Copper based babbits, composition is like this: copper 80%, tin 10%, lead 10%. The properties are like this: corrosion resistance, reasonably hard, that is, it is not going to get any abrasions when subjected to load or abrasion. Uses are like this: used where bearing pressure is high, such as railways. We summarize the chapter like this: metals and alloys which do not contain iron as main constituent are called non-ferrous metals and alloys. Example: copper, aluminium, tin, etc. Copper is soft, good conductor, corrosion resistant metal. Copper alloys are brasses consisting of copper and zinc, used in naval applications, medals, utensils, etc. Bronzes containing copper and tin, used for bells, gun barrels. Aluminium has low weight, high malleability, and good ductility. It is used for making utensils, electric cables, etc. Important aluminium alloys are duralumin, consisting of aluminium, copper, magnesium, used for aircraft components. Y-alloy consisting of aluminium, copper, nickel, magnesium, used for pistons. Magnesium consisting of aluminium, magnesium, copper, used for aircraft wings. Hindalium consisting of aluminium, magnesium, chromium, used for utensils. Bearing metals are also called as babbits. Properties are like this: number 1, low friction; number 2, thermal conductivity; and the last one is corrosion resistance. There are three types of babbits: number 1, copper based; number 2, lead based; number 3, tin based babbits. Finally, I conclude this topic, that is non-ferrous metals and alloys. I hope you understood very well. Goodbye. Thank you.
Further clarification, contact the Additional Secretary, State Board of Technical Education and Training, 7th floor, BRKR Bhavan, Tank Bund Road, Hyderabad 500063. Fax 040-322-0546.